What up, mathletes? Whoop, whoop. All right, so this is day 2 of linear transformations. And we ended up, that's true, we gotta go through this. We just went through mostly vertical and horizontal transformations. And now we're gonna start by talking about dilations, which I gotta warn you, I'm gonna be showing you notes on a piece of paper. Again, I updated your paper a little bit, so it looks a little bit different, and but you can still get the information and find the section. I'll kind of warn you as we go. It says, describe the dilation in g of x equals 2 times x as it relates to the graph of the parent function. Move through the steps to see how g of x is related to the parent function. All right, so what do we see right here? If I go, I just kind of skip to the end, you'll note, well, I need to go to the middle. We had our original f of x, and when we multiplied it times 2, it made it steeper, which we talked about that in our notes. If you remember yesterday, we actually had the notes right here of, that's translations, there we go, dilations is down there. Let me get this out of the way. Where, remember, we already wrote this down. If you're multiplying, so the big takeaway is whatever we're multiplying by, right? It's a times f of x. If our absolute value of a is greater than 1, it's going to be a vertical stretch. If it's less than 1, it's going to be a vertical compression or a horizontal stretch. If it's equal to 1, that's the identity. It doesn't change because multiplying anything by 1 just keeps it the same. So what we're talking about here, that is the wrong button. There we go. Perfect. Is we've taken this graph, we multiplied it by 2, and what did it do? It made it steeper. But notice it didn't change the original point going through 0, 0. So let's go ahead and go on to the next. We're going to talk about horizontal dilation. So that's the vertical dilation, right? It stretched it vertically. But what about if we want to stretch it horizontally? And I'm just hitting this briefly because we talked about this again yesterday. But describe the dilation in g of x equals 1/4 times x as it relates to the graph of the parent function. Okay? Well, in this case, move through the steps below. Well, what happens here is we see that we're compressing it or we're shrinking it down. What we're doing is we're taking this graph and we're making it less steep. We're stretching it vertically or horizontally. Because what we're doing is lowering everything down. It's like, because remember, when you multiply by a number between 0 and 1, right, it makes everything smaller, so it's compressing it. And so right here, we notice that the positive constant a is grouped with x, and the absolute value of a is between 0 and 1, so the graph of f of x equals x is stretched horizontally by a factor of 1a over a, or 4. So in this case, it's stretched and moved and going down like that. So just keep that in mind, okay? And what do we end up with? We end up with a graph that's much shallower than the original one we had. All right. Now we're going to talk about reflections. And again, a lot of the stuff, guys, you notice I'm just kind of hitting briefly, not getting into big super detail. We'll do more as we go on through the year and as we go on in life, but right now we're just kind of doing a cursory glance over of it, looking at it. Knowing generally if we see a graph going down, but going through the same starting point, but just, y-intercept, but just kind of going, rotating down and rotating up, we know we have a dilation going on there. Key concept, reflection of linear functions. All right, so we have two different situations here. We have the situation I want you to look at right here, where the graph of negative f of x is the relation across the x-axis, and then we have over here f of negative x, which is going to be a reflection across the y-axis. So what does that mean? Well, if we look right here, if it's negative f of x, then that means we're reflecting across the x. So whatever your xy point is, the reflection is going to go to x negative y. Notice the x isn't changing. It's the y that's going opposite, so we're just flipping everything down. So if I were to flip this and kind of play it for you, we would see this nice little animation There we go. We're going to reflect across the x. Boom. It just twists down there. See how that point went from xy to x, negative y. And that's negative f of x. Okay? Now, let's pause that one. We have our next one, which is the opposite, which is what happens if we put the group the negative with the x. Well, if we group the negative with the x, then guess what? It's going to flip across the y-axis. Let's watch this nice little animation right here. We have our f of x, our point xy, and instead of rotating down, it's going to flip across the y-axis, and we're going to have negative xy. So see how when we don't group, better pause that, when we don't group the negative with the x, it's across the x-axis. It goes from xy to x negative y. When we do group it with the x, the negative with the x, then it's a flip across the y-axis, and it's going to go from xy to negative xy. The best place I can show you that we need to see it, and I'll kind of highlight what I did here, is in notes. Okay? So what do we see? If we have negative f of x, it's a reflection across the x-axis, which means we're going from xy across the x-axis down to x negative y, right? I even wrote the correct correction. Whereas if we have the negative grouped with the x, it's a reflection across the y-axis. Boy, I wrote my y and x to look about the same. Let me correct that. Good night. Sometimes I get in a rush and just have the sloppiest handwriting. And what is that? Well, that is a reflection from the point xy across to the other side of negative xy. Okay? It's going to move points. And how does that help me? Well, if I tell you, I say, hey, we have a reflection of negative f of x of the point, I don't know, let's get a point 3, 4. Well, what do I know? I know it's going to go to x negative y, so that's going to go down to 3 negative 4. On the other hand, if I say, hey, I'm going to do f of negative x reflection on the point 3, 4, well, what's it going to do? Well, it's actually going to scoot to the left to the point negative 3, 4. Because it goes from xy to negative xy. Okay? Awesome. Good stuff. Remember to always pause what you need to pause if you need to write stuff down. I'll put my other parenthesis there. So we're going to do reflections of linear function across the x-axis. So because the negative is not grouped with the x, all right, we have g of x equals negative 1/2 x. And to go ahead, right here we have x equals f of x, right? Or f of x equals x. That's what this table is, f of x equals x, right? Because all the points are the same. Negative 2, 0, 0, 4, 4. So to go ahead and to change this to negative 1/2 times that, right? That's negative 1/2 times that. And so we're going to have f of x times negative 1/2, which means we're going to add some rows here. That negative is going to reflect it across the x, and that 1/2 is going to dilate it down a little bit. So what's negative 1/2 of f of x right here? Which is going to be, what's negative 1/2 times negative 2? Negative 2 times negative 1/2. Negative negative is positive. 2 halves make a whole, so this is going to go to 1. So my new point is going to go, so I'm going to go from this point, negative 2, 2, and I'm going to dilate it, and I'm going to reflect it to the point negative 2, 1. So it's going to reflect right here. How about the point 0, 0? Well, negative 1/2 times that is still 0. So I'm still going to have my point at 0, 0. And then last of all, I'm going to look at this 4. Well, what's negative 2, or negative 1/2, excuse me, times 4. And let's see, 2 goes in 2. That's going to end up being negative 4 halves, which is just negative 2. And what do we see right there? it now goes to -2. So let's do that. So we were at the 0.44, which is 1, 2, 3, 4, 1, 2, 3, 4. And this is going to the 0.4, -2, 1, 2. Boom. And now we see this line that's emerged right here. It's shallower than this one because we dilated it by a factor of 2, right? Or -1/2. We reflected it and dilated it by a half. All right, we made it a little shallower. Okay, so that's reflecting across the x-axis. Notice how we just multiplied. We took whatever was being multiplied times the x and multiplied that times our outcome of f of x to be able to apply the transformation. Pause it if you need to. Let's get rolling. Now we're going to reflect, practice one more extra example across the x-axis. Let's just roll with it and see what happens. So the negative is not, well, come on, that's like cheating, is not grouped with the x. So the graph of f of x, g of x, excuse me, equals -5x, is the graph of the parent function vertically stretched and reflected across that x-axis. Because it's not grouped, its x-axis is the reflection. I need to reset this, though, for the time I actually teach it. My gracious. Right. Now we're going to do reflections across the y-axis. So let's look at this first one. We're going to see the negative is grouped with the x. We have g of x equals -3x. Okay. Gotta get that out of the way. There we go. All right, so remember in this transformation, when the negative is grouped with the x, it now becomes, it goes from our xy to become, we're going to move to the left to go -xy. So the y doesn't change, but the x does. And we're going to multiply, in this case, not just negative, but -3 times the x. So if I'm going over here, what's going to happen to my x? Well, I'm going to have -3 times -1, which is going to equal 3. And then -3 times 0, that's still going to be 0. And what's -3 times +1? Well, that's going to lead me to a -3. So let's see, let's graph that, see what happens. We're going to end up with 3, -1. So 1, 2, 3, -1. Still got 0, 0. And then we're going to have -3 once. -1, 2, 3, 1. Now what happened here is we flipped across the y and increased. And let's look at this. What do we got here? Let me try and draw this bad boy. Oh. Actually, it's a pretty amazing line I just drew there. So we've got a nice little dilation as well as a flip across the y-axis. Okay, let's erase this. Pause if you need to. All right, we're going to try another one of these. Let's take a look. Describe how the graph of g of x equals -1/6x is related to the graph of the parent function. Well, the negative is grouped with the x, so the graph g of x, the graph is the parent function, horizontally stretched and reflected across the y-axis because it's grouped together. Boosh, right there. All right, it's time for homework. Let's get rolling on this. Peace out.